Hi, welcome to educators.com. I'm Shravanti, your Hadoop instructor. In this module, we are going to discuss about joins in Hive, join examples, map join, Hive views, and Hive indexes. Joins in Hive. So similar to your SQLs, here also we do have a different types of joins such as inner joins, full joins, left outer joins, right outer joins. Different types of joins are available. Based on our requirement, what kind of the joins you wanted to use, we can specify that. Especially if you're looking into the need of the join, when you're having the multiple data sets, and if you wanted to combine those two data sets together to draw a conclusion or to draw a result, in that case, we will be identifying which key is the foreign key. That is nothing but, let's assume if we are having the two tables like employee table and the department table. In the employee table, let's assume that it is consisting of employee ID, employee name, and then the department ID. And we do have the department table. In that table, it's consisting of the department ID and the department name. So if you wanted to join these two tables like employee and the department, so what you can see over here is the department ID in the employee table will be the foreign key, which will be pointing to the department table department ID. So that whenever you wanted to combine these two data sets together, it is going to be used that specific key. So if you see this inner joins, in this inner joins, especially when you're joining the two tables, whenever you are having the same value in the both the tables, that is, let's assume the department ID is the 101 in the first table, employee table, then whenever you find the correct match in the second table, which is the department table, then that particular record gets fetched up. That means, in simple words, there must need to be at least one match on that particular common columns. So let me log into our Cloudera Quick Start VM and show you how exactly these different types of the joins works. I have just logged into my Cloudera Quick Start VM and let me log into the Hive shell. So now the two tables, the employee and department tables, were already created, and now I have loaded the data with the help of the load data local impact. You can see those two tables. Select star from EMP, which consisting of the employee ID, employee name. You can see here this consisting of the employee ID, employee name, salary, and the department ID. And also, if you see this department table, which consisting of the department ID and the department name. So if you observe this, here is a 101. So whenever I'm joining the inner, I'm performing the inner join, wherever there is a matching record, that is 101 is here and here. So I'm going to get the entire record. So if you see this, I have executed the select employee star. That star is it displays all the content in the employee table, and department star is department table, all the content from two tables like employee and the department is the two different tables. And with the help of the join clause, I'm joining these two tables, employee and the department. And by specifying the on, we are giving those details like what is the foreign keys. And here, if you see this employee table department number is equal to, must need to be matched with the department table department ID. Whenever you have such kind of the match, then it will display you the records, whichever is matching in both the tables. So when you submit this particular inner join or any kind of the join, it submits your job to the MapReduce. So you can see here, your job got submitted, and internally behind the scene a MapReduce job got submitted, and you can see the result on top of your screen finally. Alright. So if you observe the content, these details are related to the first table, and these details are related to the second table. Similar way, the first 4 fields are related to the employee, and the next one are related to the department. So whatever the queries you wanted to write, you can directly specify it as part of this. And the similar way, there is something called a full outer join. That means where in case of the inner joins, you will be having the same kind of the data. Like whenever you are having the matching records, it displays. But in case of the full joins, irrespective of the matching records, it displays all the columns. And wherever there is no matching record, it displays with the null. You can see it over here. The one is the employee table and other one is the department table. Instead of the normal inner join, we are giving it as a full outer join. These columns are same. Employee table department number equal to the department table department ID. So you can see the results. All the table records, you can see it, and wherever there is no matching records, you can clearly see that it displays with the null records, null values. We can see the result of the left outer join over here, and see there is no matching record for the column 104 value. So here it is displaying with the null records. Similar way, we do have something called a left outer joins and the right outer joins. That is nothing but, in case if you wanted to display the left side of the table, like if I take the employee and the department of the two tables, if I wanted to display all the data from the employee table, irrespective of the matches are there or not, then you can use the left outer join. And also if you wanted to display all the records from the right side of the table, then you can use the right outer join. And wherever there is no matching records, then it displays with the null values. And here to specify the right outer joins and the left outer joins, here you can now directly specify which type of the joins you wanted to use it with the help of the right outer join or full outer join or left outer join, the help of the on clauses. Join Hive example. So here, let's take our movie data set, which consisting of the two different data, which is the UDOT data, which consisting of all the movie related information, movie ID, and the user IDs, and the date, and the timestamp, ratings. These are all the some of the details which you can see in the movie lens. And to see the movie name, those are available as part of the some other file, which is u.item file. So let's create those two tables and let's load the data into those two tables, and then let's combine these two tables, u.data and u.item tables, movie lens and movie lens information tables, to conclude how many times each movie has been rated. So here I'm creating a table. You can see here. Let me create a table which is movie lens. Create table. Table name is a movie lens 1, and which consisting of the user ID, movie ID, rating, and when the rating has been given. The fields are terminated by the tab, and we are going to store it as a text file. So let me show you the input file, how exactly your u.data looks like. I have attached this u.data file to the video. You can directly drag and drop to this Cloudera Quick-Start-VM. You can see it is on top of the screen, which consisting of the user ID, and this is the movie ID, rating, and this is the timestamp when the rating has been given. Likewise, let's assume this movie is there. A lot of times the same movie can be reviewed, and people can be rated, because this is a 196 user came in and they rated. And after some time, the another user comes in and they will be rating the same movie again. So we wanted to know like how many times each movie has been rated. So to load this particular data into our Hive, what we are going to do is, first we created a table called a movie lens 1 table, and now we will be loading that data into our movie lens 1 table. And here I'm executing load data local impact. My file is available in the desktop, and loaded into the movie lens 1. So to cross verify whether it has been loaded or not, select star from movie lens 1. See here our data is loaded. Similar way, just download that u.item file also into your Cloudera. Just drag and drop that file into your Cloudera. Quick start VM desktop. Let me show you how exactly that file looks like. This is the u.item file. This consisting of a movie ID and this is the movie name and when the movie has been released and what is the IMDb URL. These are all the genres, like whether the movie is action, comedy, or what kind of the movie it is. So if you wanted to find it out, like the full name of the movies and how many times each and every movie has been rated, let's join these two tables, like u.data table and u.item table. So first let's create a table and let's load this data into our Hive. So here we are creating a movie lens movie info table which consisting of the only two fields I wanted to take. One is the movie ID and the movie name. And now let me execute the load.local impact and let me load the data into the system. So here I'm just loading the data into the system and you can see select star from movie lens underscore movie info 1. You can see these two tables data. So let's join these two tables and let's get the information. So here I'm joining these two tables, movie lens and the movie lens info table, and to find it out how many times each movie has been rated. So if you see this, we are joining these two tables. One is the movie lens table and joining with the movie lens movie info table. And as I wanted to get all the information from the left hand side table, so I'm using the left outer join. And here on the join column is first table movie ID must need to be equal to the second table movie ID, u.item.movie ID. That is the reason why with the help of the join class which we are executing. And here we wanted to get the movie name. So if you see this, I'm displaying the movie name and how many times that movie has been rated. That is the reason why count star. And here I'm using the group by because I wanted to group it by a movie name so that whoever is having the same movie name, whoever rated the same movie name, all these records can be grouped together. So that is the reason why in a simple group by and I'm going to find it out the count star is going to display the how many times each movie has been recorded. Yeah, so this order by is not mandatory. So this is nothing but I wanted to display it in the sorted manner. Like descending order, I wanted to display whichever movie comes based on that particular rating. So this is the query which will give you the information related to the how many times each movie has been rated. You can see the results. You can see the results like the movie name and also this rating. So if you observe, this is coming from the second table, which is a movie info table, and this rating is coming from the first table. So that is how you will be joining these two tables and combining the results. And in the Hive, we do have some special types of the joins, which is a map join. Map join is nothing but it's similar to your distributed cache, like whenever you are having a small table. So whenever you're having a small data set, then what you can do is you can directly load that into the system's main memory. So here how we will be specifying, let's assume that in one of the table is quite less in size. So in that case, if you wanted to load that into the memory of all the data nodes, like memory of all the machines, then you can directly specify that with the help of the slash star. You can see the syntax over here, select the slash star and with the help of the map join, and you can specify which table you wanted to, which is a smaller table which you wanted to load it into the memory. And then you will be using these, the rest of the things are normal, like employee table and the department table. I'm using the inner join, and on which column you are using it, even we can specify that columns as well. And so we can execute this, select, and whatever the earlier example which we have seen, the employee and department is a smaller table. So I wanted to use the map join, so I have defined it with the help of the dot star and the slash. With the help of that, we define it over here. And we are joining these two tables, which is the employee table and also the department table on this specific column. Employee table department number equal to the department table department ID. So there is no difference in the output if you use the map join or not, but the only thing is it uses faster because it uses the all the data is already available in all of these machines. So you need not even move into the different data nodes to execute this. So you can see the final result. So when you compare with the huge amount of the data set, you can clearly see that how fast it uses. So this is one of the the optimization techniques which we will be using it. The map join whenever you see the smaller size table in place. And Hive views. Till now we have seen how to create tables and how to perform the joins and this stuff. So here the view is similar to your SQLs also. Oracle SQL also will be having the views. The Hive view is mainly whenever you wanted to execute a bigger query, and if you wanted to share the bigger query with your business analyst team. So instead of sharing the entire 3 lines of the query, what you can do is you can create a view on top of that query and you can share that view details to them. That is nothing but when I say that view or the Hive view is purely a logical construct. It's just a logical way to hide all of these difficulties, and you can just create the view and give it to them. And also when you compare with the normal views, SQL views with these Hive views are read-only. You can't update these specific views. So where in case of the SQL, those views you can even update it as well. So here mainly whenever you wanted to restrict any of the users to access a particular some data tables, then what you can do is you can just create a view on top of that table and just give it to that particular view name to them so that they will be accessing that view, like with the help of select star from executing that view name is going to display the details. So similar to the create tables, here also you will be just using create view and view name, but here with the help of the as statement and whatever the biggest query is there, that query you are going to write it after the as, so that internally that query get executed and your results get displayed on top of the screen when you use it with the view name. So here let me create the view in the Hive. Create view, this is the view name and this is the query. Let's assume that I just wanted to do it from the select star from movie lens and where rating is equal to 5 and movie ID is equal to so and so, or else it can be n number of the conditions also you can put. So now this particular view you will be sharing it with your team, like the BA team for example. So what they can do is instead of executing the biggest query, they will be simply executing select star from movie lens underscore view 1. That's it. Once they execute this thing, automatically behind this particular view this query is there. So that query gets executed and you can see the results on top of your screen. See this? If you observe the results, you can see all the results rating is 5 itself, and also here the movie ID is 242 itself, right? So that is nothing but automatically you can see you can get the results based on this particular conditions, whatever the query is returning on the top of that view. And Hive indexes. So if you want to improve the query of your, the performance of your Hive queries, then even you can implement your Hive index. So how exactly it improves the performance is nothing but if you do not have the Hive index, what it does is whenever you're having a query which consisting of the where clause, so your entire table is going to be loaded whenever you are having that where clause, and then it will processing that particular data. But if you already created index and specific column, then what it does is only the portion of the file needs to be loaded and it gets processed. So obviously whenever you're processing with the whole bunch of the millions of the records and a small set of the records when you create the index, the time differs. So these indexes are quite faster, and it makes sure that your data gets executed. Your data get pulled up now faster, and it improves your query speed in that way. So we do have a different types of the indexes are available as part of this. And here if you see, if you want to create an index, you can use the create index and which table you wanted to create an index and which table, and here create index, index name on table and which table you wanted to create an index, and you can specify the column name. That's similar to SQL also. Usually we will be choosing a specific column, and the specific column we will be choosing the indexes. And here you can mention that compact, these are the compact indexes. So you'll be having a different types of the indexes like a compact or bitmap. So here you will be using that compact indexes. Yeah, so here you can even use that deferred rebuild. That is nothing but it initially creates without any of the index, and after that you are just using the alter statement to rebuild that particular indexes. So in this module, we discussed about the different types of the joins like inner join, outer join, left outer join, right outer joins. And also we have discussed about the very important join, which is the map joins. And we understand that the importance of the map joins is to load the data, whichever the small table is there, it will be loaded that into the memory to improve the performance of that query. And also we have understand that how exactly the views are going to be created and how the views are useful in sharing the complex query to your business analyst, and you can create a view and share it with them. Similar way, you can even create the Hive Index to improve the performance of your queries. You can choose a column, and on that particular column you can even create an index, which can be a compact index or the bitmap index. Thank you. Let's catch up in the next module.